Hi, in this video I'm going to talk about chapter 9 of the book, okay, which is sequence and series. So the very first thing we will discuss is sequence, okay. What do you mean by sequence? A sequence usually we denote by a sub n, where n runs from 1 through infinity, okay. A sequence denoted by a sub n, and you write parenthesis 1 through infinity, is an ordered list of numbers. It will be a1, a2, a3, and so on, okay. So that is called a sequence. So usually the sequence is written as an and then parenthesis n equals to 1 through infinity, or a sub n inside the curly braces n equals to 1 through infinity, okay. So this a1 is called the first term. This is the first term, this is the second term, this is the third term, and so on. So there are infinitely many terms because we have n equals to 1 through infinity, okay. When n is 1, it is a1. When n is 2, it is a2. When n is 3, it is a3, and so on, okay. So now how do I find out, how do I write the terms? Usually the sequence is given as by the nth term, okay. You write this is an is the nth term, right? And then the value of the nth term will be given to you, and then you find out the terms of the sequence depending on that, right? So what will be a1 on this sequence? It says list some terms of an equals to 1 over n. To find out a1, you replace n by 1. You will get a1 is 1, right? So the first term is 1, comma. If you put 2, then a2 will be 1/2, right? a2 is 1/2, right? Similarly, if you put n equals to 3, it will be a3. a3 will be 1/3, right? And if you put n equals to 4, then a4 will be 1/4, right? And keep doing that, okay. So you keep doing that. So this is how you find out the terms of the sequence, okay guys. Now next example, list some terms of an equals -1 to the n plus 1 times n over 1 minus 2n. So similarly we put n equals to 1, n equals 2, n equals, so this is the nth term given, right? An is the nth term given. By the help of the nth term, what we are going to do is we are trying to find out all the terms. So let's plug in n equals to 1. What do you get? If you take n equals to 1, you will get -1 to the 1 plus 1, that is -1 to the 2. That will make it positive, right? So 1 over 1 minus 2 times 1, 1 over -1. So what do you get? Then it is -1. That is the first term, okay. Let's plug in 2. -1 to the 2 plus 1 is 3. So -1 to the 3 is -1 times 2 over 1 minus 2 times 2, right? So -3 here, 1 negative sign here. So you get 2 over 3, just 2 over 3. 2 over 3, right? That's what you get. That is the second term. So third term is you plug in n equals to 3. What do you get? If you plug in n equals to 3, you will get -1 to the 3 plus 1. -1 to the 4, that is +1. Now 3 over 1 minus 2 times 3 is -5, right? So 3 over -5, that is -3 over 5. You see that? That is the third term. Let's find out the fourth term. So plug in n equals to 4. a4 will be -1 to the 4 plus 1, that is -1 to the 5, which is -1. And then 4 divided by 1 minus 2 times 4 is -7, right? So -1 times 4 will be -4 over -7. That will be 4 over 7. And so on. Okay, so that's how we find out the terms of a sequence if nth term is given. This is the nth term. First term, second term, third term, and then you can write nth term, right? And then keep writing that. And then n plus 1th term, n plus 2 terms, and so on, okay? Usually to write the sequence, you write the nth term. You write the nth term and you find out the other terms by the help of nth term. Okay, guys. So let us see example. Next example. It says find the AN if the sequence has the terms like this. So the first term is 1/3. Second term is, so what is A1? And then what is A2? A2. And what is A3? Okay, let us find out these A1, A2, A3, and then we will see how the terms are going, and then we will guess AN. Okay, we'll guess AN. A1 is 1/3. A2 is 2/9. A3 is 3/27. 27, right? So you can write this as basically 1/3 to the 1, right? And this can be written as 2/3 to the 2. You see that? And this can be written as 3/3 to the 3. So what is AN then? So AN, you can write AN as, you see that? Whenever there is 1, there is 1 and then 3 to the 1. If there is a 2, if the subscript is 2, then there will be 2/3 to the 2. If subscript is 3, then 3/3 to the 3. Then n, if the subscript is n, you can write n over 3 to the n. Right? So this is the nth term. So that's how we find out from this. So basically you just look at the patterns. What is the pattern there? Okay. So 3 to the denominator is the exponent of 3. And numerator is just whatever term is. If the first term, numerator is 1, second term, numerator is 2, third term, numerator is 3. So the nth term must be, numerator must be 3n, right? And then in the denominator, the first term has 3 to the 1, second term has 3 to the 2, third term has 3 to the 3, fourth term has 3 to the 4. So nth term must have 3 to the n. So this is how you find out the nth term. Okay, guys? So the next concept is limit of a sequence. In some sequence, the terms of the sequence approach to a number L. If we keep evaluating more terms, if you keep finding the more and more and more terms, then you will see that these terms are going towards a certain number. Okay, you will see that the terms are going towards a certain number. Okay, suppose that the terms of the sequence are closer and closer and closer to the number L, then L is called limit of a sequence. Okay, for example, let us suppose that an equals to 1 through infinity. The sequence is given by an equals to 1/2 to the n. Then how does the term look like? A1, the first term will be 1/2. A2 will be 1/2 to the 2, 1/4. A3 will be 1/8. A4 will be 1/16, and continue that. You see that? What is the value of 1/2? 1/2 is 0.5. This is 0.12. This is 0.25. This is 0.125. This is 0.0625, and so on. You see that? These terms are heading towards 0. If you keep continuing, like finding more and more and more and more terms, you will see closer and closer and closer and closer to 0. Okay, so meaning that if you keep evaluating the terms of the sequence, if the terms are getting towards a number, a fixed number, then we call that number L is the limit of a sequence. Not all of the sequence have this property. Some of the sequence, if you keep evaluating more and more terms, then the sequence is more random and getting the values of the terms are getting random and getting bigger and bigger and bigger. So in that case, the sequence is not approaching to a number L, to a finite number L. Rather, that is getting bigger and bigger and bigger, means the sequence does not have a limit, or the sequence does not converge. If a sequence has a limit L, a finite number, a finite limit L, then we call that L is the limit of a sequence, and the sequence converges to L because it is getting towards L. Okay, and this sequence, basically the sequence we see here, is basically, it is a convergent sequence. It converges because when you calculate more and more and more terms, then the value of the terms are getting close to 0 and 0 and 0. So basically this sequence has limit 0. How do we write that? Is we write limit n tends to infinity an equals to 0. Okay, limit n tends to infinity an is equals to 0. That's how we write if the sequence converges. So if the sequence is different from 0, or we write L, right, if the sequence approaches to L, but in this case L is 0, right, L is 0, but on other cases the L can be any fixed number. Okay, that's how we write if the sequence converges to 0. So we will learn about what types of sequence converge later. So what are the methods to find out convergent sequence, to determine if a sequence converges or not, and then what will be the limit? We will discuss that later. But for now, how do we know a sequence converges is if you keep evaluating the terms of the sequence, then if you find a certain pattern that the values of the terms are approaching closer and closer and closer to a number L, then L is the limit of the sequence. And we write limit n tends to infinity an is equals to L, and L is the limit, and we also call that the sequence an converges to L. Okay, you see that? Notice that the second term is 0.25 close to 0. You see that? It is 1/4 is 0.25 close to 0, and the third term is 0.125 close to 0. Okay, the fourth term is 0.063. So this is just that 0.063 distance from 0, far from 0. Okay, and if you find out the 10th term continue that way, you see that the 10th term is 0.00097. So this is that very close to 0, and so on. Okay, so you see that when you calculate more and more terms on this sequence, you see that those terms are getting closer and closer and closer to 0. That's why the limit of an is L, which is L equals to 0. Now, so this is just the wordy way to write the limit of a sequence, right? But what is the mathematical way? What is the mathematical definition of writing a sequence? Is this: let A sub n curly braces be a sequence. A number L is called limit of a sequence an if for each epsilon greater than 0, epsilon is a tiny number I'm considering, just epsilon greater than 0, there exists a term n which is also positive, such that the difference between an and L is less than epsilon. Whatever epsilon you pick, you will find a term, okay, you will find a term that will give you so for any epsilon, this epsilon is a small number, whatever is small you pick, for any epsilon you will be able to find out a term such that all the terms after that term will be within epsilon distance. This is an minus L less than epsilon, means the distance between an and L will be less than that epsilon. That's what it means, right? Whenever n is greater than n. What does that mean? That means if you pick the terms after nth term, capital nth term, like after an, after nth term, all the terms after that will be within epsilon distance from L. You see that? That is the terms getting closer to L after nth term. Okay, how much closer is epsilon closer? For example, suppose that epsilon is 0.1. Okay, so if you find out the terms like a1, a2, a3, a4, a5, a6 and so on, then in this case, on this example you can think, in this case, after certain terms, all the terms of this sequence will be within 0.1 distance from 0, from L, within epsilon distance from L. Let us look at this example here. This is just the abstract example. We don't know what are an. Suppose that these red dots are, this is a1, this is a2. See, at 1 this is a1, at 2 it is a2, 3 a3, at 4 it is a4, at 5 it is a5, at 6 it is a6, at 7 it is a7, and at 8 it is a8, a9, a10, a11, a12 and so on. Look at this. In this example, you see that all of the terms after first term, second term, third term, fourth term, fifth term, sixth term. So after fifth term, all of the terms are within the epsilon distance. Suppose this is L. This line is L here. This is L. Okay, this is L. Now we see that after the fifth term, after the fifth term, all of these dots after that are within the, this is L plus epsilon, this is L minus epsilon, within the epsilon stripe. We call epsilon stripe. This is L plus epsilon, L minus epsilon. So within epsilon stripe from L, that means after n greater than 5, all the values of the terms, all the terms of an are within the epsilon distance from L, or within the epsilon stripe from the number L. So that's why L is the limit of a sequence, and we write limit n tends to infinity, a sub n is equals to L. That is, L is the limit of sequence. Also, we call, if L is finite, if L is less than infinity, if L is finite, then we call an converge. Okay, if L is infinity, then we call an diverge. Okay, so we will see some more examples. Okay, guys. All right. Let us talk, how do we know whether a sequence converges or diverges? How do we find out that? How do we evaluate the limit? Okay, because if a sequence converges, then it has a limit L, right? So L can be any number there. So if the sequence diverges, then it isn't going to a number L, right? If you find out more and more terms, then the terms are randomly going up or down. So they are not going close to a number. That's the diverse case, right? So converge means they are going to a certain number there. Okay. So let us see a very short and very basic method to find out limit of a sequence. You know how to find out limit of a function, right? So it is similar to the limit of a function. Limit of sequence is very much similar to the limit of a function. Okay, guys. So here, let us say that convergence of a sequence an is limit n tends to infinity an goes to L. The limit of a sequence an is L if limit of a function is L, where fn is equals to an. So f of x is equals to a sub x. If you replace n by x, then it will be denoted by fx, and if the limit of the function fx is L, then the limit of a sequence fx will be L as well. So for example, let us see this example. Does an equals to 1 over n converge? To see if this an converges or not, what we will do is we will find out fx. What we will consider fx? Let fx is equals to, fx is a sub n. A sub n is that, so 1 over x, right? So fx is equals to, f of n is an, so fx will be a sub x. So if you replace n by x, then you will get 1 over x there, right? Fx is 1 over x. So what is the limit of, let fx is 1 over x, then what is the limit of fx? Limit n tends, so x tends to infinity. You see that x tends to infinity here. Limit x tends to infinity fx is equals to limit x tends to infinity 1 over x. So when x tends to infinity, what is that? Where does this 1 over x goes? It goes to 0, right? It goes to 0 when x tends to infinity, right? So since the limit of fx is 0, hence limit n tends to infinity an is also 0. That's what we find out. Okay, if limit of fx is 0, but what is fx? Fx is same as a sub n, same as a sub n, but n replaced by x, right? Same as a sub n, but n replaced by x. If that goes to a number, or if that fx has a limit, then a sub n also has the exactly same limit. Okay, that's what it is saying. And do you remember the section 5.6? I think that isn't that Lopital's rule? Okay, do you remember this rule? Lopital's rule. Let me write down that. So Lopital's rule. Lopital rule. What does it say is, when you plug in the limit directly, if you get infinity over infinity or 0 over 0, then you find out the derivative of the numerator separately, derivative of the denominator separately. That's what the Lopital rule say. Okay, so we do the same thing here as we just did. So I want to check if this sequence converges. The value of the sequence a sub n is n over e to the n. That's what it is given. So let's do let f of x. What should be f of x? It should be x over e to the x, right? So then let's find out the limit. Limit x tends to infinity f of x is equals to what? Limit x tends to infinity, right? And then x over e to the x. So if this limit exists, to a number. If this limit converts to a number, then this limit converts to the same number. That's what this theorem says that, right? That's what we're trying to find out. Now, what is this limit on the right side? If you plug in the limit, you will get infinity over infinity. Did you see that? Infinity over infinity. Okay, infinity over infinity. So we can use L'Hopital's rule. So if you use the L'Hopital's rule, what do you get? Equals to limit x tends to infinity. So to use the L'Hopital's rule, what do? You find out the derivative of the numerator. You get 1 over derivative of the denominator is e to the x. Okay, we use the L'Hopital rule one time here. Now let us plug in the limit. What do you get? 1 over e to the infinity. How much is that? That is 0, right? So the limit of this is 0. So limit of the function is 0. So what we can say is hence limit of n tends to infinity, an is also 0, because the limit of x tends to infinity, fx is 0. Okay, that's what we get. So basically, I mean, if you don't want to replace n by x, you can just do it directly, but don't forget to use L'Hopital's rule for n. You need to find out the derivative with respect to n like that. Okay, you can do it directly as well. You don't have to actually write. So just take the limit of the nth term, an. Just take the limit of that. You can do like this, right? So you can basically do limit n tends to infinity, an is equals to limit n tends to infinity, n over e to the n, right? And if you plug in the limit, then what do you get? You get infinity over infinity. So you can use L'Hopital's rule, right? So let us use the L'Hopital's rule there. You get limit n tends to infinity. The derivative of n is 1. We are finding with respect to n. You can think that way, okay? Over the derivative of e to the n is e to the n itself, because we are finding with respect to n. Okay, you can think that way. Now this is 0, hence the limit is 0. You can do like that. Okay, guys, how about this example? Evaluate limit n tends to infinity an, where an is e to the n plus 1 over 2n plus 3. Okay, we will use L'Hopital's rule again, but in the exponent. Okay, so let us do that. So limit n tends to infinity, a sub n, okay, is equals to, you can write e to the limit. You can move that limit to the exponent, right? N tends to infinity, and then n plus 1 over 2n plus 3. If you plug in the limit in the exponent directly, what do you get? You get again infinity over infinity there. You see that? That's what you will get. The limit will be infinity over infinity. So you can use the L'Hopital's rule only for the exponent. Okay, so that's what I'm trying to do here. Equals to e to the limit, okay, n tends to infinity. Why did not I write the limit here? Because there is no n in the base. The n is only in the exponent, and limit n tends to infinity applies only in the exponent function. That's why. What is the derivative of the numerator? That is 1, because the derivative of n plus 1 is 1 with respect to n, right? It is like x plus 1 over 2x plus 3. You see that? And then find out the derivative of with respect to x, you get 1. And then on the denominator, if you find out the derivative, you will get 2, right? So how much you get? Then e to the 1/2. That is root e is the limit of this sequence. Okay, that's the limit of that sequence. So in short, that's what I'm writing. In short, if limit n tends to infinity, a sub n is L, then the sequence converges to the limit L. So actually, once you know the idea, you don't have to change into fx. You can just do it directly. That is perfectly fine. But just to link with the L'Hopital's rule, I just changed to x and then did that way. You can change to x and do that way. If you want to change, if you wanted to change to x, how would that look like? We would write let f of x is equals to e to the x plus 1 over 2x plus 3, and you will find out the limit of the numerator. You will get 1/2, and then you plug in, you will just come back, right? So limit of fx will be e to the 1/2. Therefore limit of an will be e to the 1/2 as well. You could do that way. Okay, so either way, that's fine. So let us do this example. Okay, very last example before I talk about the properties of the limit. Okay, guys, so does the limit a sub n converge, where n is given as n square over 2 to the n minus 1. Okay, so how about this one? So let me take limit n tends to infinity, n tends to infinity, a sub n is equals to limit n tends to infinity. Okay, it is n square over 2 to the n minus 1. If you take the limit n tends to infinity, you will get infinity over infinity here. You see that infinity, because infinity square is infinity over 2 to the infinity is also infinity, minus 1 will be infinity, because you're subtracting just 1 from a big number, right? Now, since it is infinity over infinity, we use L'Hopital's rule. How would that look like? This will be limit n tends to infinity. You see that? Now use the L'Hopital's rule. What is the derivative of n square? That will be 2n. 2n divided by, what is the derivative of 2 to the n? Because the derivative of 1 will be 0. What is the derivative of 2 to the n? It will be 2 to the n times natural log of 2. That's what you get, natural log of 2. Now if you plug in the limit again, you will get infinity over infinity. You see that? You will get, still you get infinity over infinity, because there is still n. That's why. Okay, so now what I'm going to do again is I'm going to do the L'Hopital's rule again. If I do the L'Hopital's rule, what do I get? You get limit n tends to infinity, the derivative of 2n is just 2, because we are finding with respect to n, right? Over, what is the derivative of 2 to the n? Because this is just a constant, right? Natural log of 2 is just a constant. So find the derivative of 2 to the n. It is again 2 to the n times natural log of 2. There is one more natural log of 2 times natural log of 2. Now let us plug in the limit. N tends to infinity. 2 over 2 to the infinity times natural log of 2 times natural log of 2. It is 2 to the infinity in the denominator. Huge number. So 2 over huge number will be 0 again. So the limit of an is also 0. Okay. So this sequence converges to 0. We can say like that. Okay. All right. So let me talk about the properties of the limit, and then I will end this video. Okay. So suppose that the limit of a sequence an is L, and suppose that the limit of a sequence bn is k. Okay, then if you multiply an by c, a constant c, then the limit will be c times L. Okay, meaning that whenever you find out the limit, you can pull that constant out. Okay, and then find the limit of an only, like that. That's what it is saying. Also, if there is a sum and difference of the two sequence, then the limit will be sum and difference also, because an goes to L plus minus bn goes to k. There may be plus or minus there. Okay. Similarly, if you are multiplying two sequence, then the limit of the product of the two sequence is equals to the product of the limit. Okay, guys. And last, the fourth one is the limit of the ratio of the two sequence is same as the ratio of the limits, because you find out the limit of the numerator separately, limit of the denominator separately. You can do that too. And as I mentioned, the limit of function of sequence an is same as function of the limit of an. Okay, as we did, it is, you see that it was e to the an, right? An is n plus 1 over 2n plus 3. It is e to the an, but the limit of an is, you see that here, what we did here is an is equals to, it is like an is equals to, or you can write function is equals to a to the some bn thing, right? So the limit of an will be e to the limit of bn. You see that limit of bn is 1/2, right? Because bn, that's I denoted that by bn. So e to the bn. So find out the limit of the bn only, that exponent only, and I got 1/2. The limit is 1/2. So the limit of the an is basically e to the 1/2, that is root e. That's how we find out, right? So you can move that limit anywhere you want to. That's what it is saying. Okay, guys. So these are the properties of the limit, and we will talk about more techniques of finding the limit in the next video. All right. Thank you.